The colors of stars are not just for beauty. They reveal their surface temperatures. Blue stars are the hottest, with temperatures exceeding 30,000 degrees Celsius. Red stars, on the other hand, are much cooler, at around 3,000 degrees. The colors are like nature's thermometer in the vastness of space. Our sun, which appears yellow to us, is classified as a G-type main sequence star, often called a yellow dwarf. Despite its name, it is not particularly small, but rather an average-sized star in the universe, with a surface temperature of around 5,500 degrees Celsius. Many stars in the universe are not solitary like the sun. Instead, they form binary or multiple star systems. In these systems, two or more stars are bound together by gravity and orbit a common center of mass. These celestial dances can last billions of years. The Alpha Centauri star system, our closest stellar neighbor, is a fascinating triple star system. It includes two stars similar to the Sun, Alpha Centauri, A and B, and a dim red dwarf star called Proxima Centauri, which is the closest individual star to Earth. Proxima Centauri, located just 4.2 light years from Earth, holds the title of the closest star to our solar system. If we traveled at the speed of current spacecraft, it would still take over 70,000 years to reach it. This reminds us how vast and challenging space exploration truly is. When you look at the stars, you're essentially looking back in time. The light from the nearest stars takes years to reach us, while light from distant galaxies can take billions of years. Some of the stars you see tonight might have already gone supernova long ago. The brightest star in the night sky is Sirius, also known as the Dog Star. Located in the constellation Canis Major, Sirius is only 8.6 light years away. Its brightness is due to its proximity and its inherent luminosity, which is 25 times greater than that of the Sun. Despite being one of the brightest stars we can see, Sirius is not as large as many other stars in the galaxy. Its brilliance is more a result of its closeness to Earth, rather than its size or temperature, making it an excellent guide for stargazers. Stars are born in massive clouds of gas and dust called nebula. These stellar nurseries, such as the famous Orion Nebula, are regions where gravity pulls material together until nuclear fusion ignites, creating a newborn star that lights up the cosmos. The Orion Nebula, located in the sword of the constellation Orion, is one of the most studied regions in the sky. It is a glowing cradle of star formation, visible to the naked eye, and home to thousands of young stars in various stages of development. Some stars end their lives as planetary nebula, leaving behind beautifully intricate shells of gas and dust. The Cat's Eye Nebula and the Ring Nebula are examples of this stunning cosmic artwork. Astronomers use spectroscopy to study the light from stars. This technique reveals the elements present in a star's atmosphere, allowing scientists to understand its composition and even its age. The Hertzsprung-Russell diagram is a fundamental tool in astronomy. It categorizes stars based on their brightness and temperature, helping astronomers understand their life cycles. Ramée bursts, the most powerful explosions in the universe, often occur when massive stars collapse into black holes. Some bursts last just seconds, but release more energy than the sun will produce in its entire lifetime. In the distant future, the night sky will change. Stars we see today will move due to their proper motion, and constellations will shift into completely new patterns over thousands of years. A star's life expectancy is closely tied to its mass. Small stars, such as red dwarfs, are frugal with their nuclear fuel and can burn for tens of billions of years. Massive stars, however, live fast and die young, often lasting only a few million years, before exploding in a supernova. Hypergent stars are the giants among giants. These colossal stars can be up to 1,000 times the diameter of the Sun. One of the most famous examples, VY Canis Majoris, is so large that, if it replaced the Sun, it would extend beyond the orbit of Jupiter. Stars do not twinkle because they change their brightness. The twinkling effect, called scintillation, happens because Earth's atmosphere bends and distorts the light as it travels to our eyes. In space, stars shine steadily. The Sun accounts for 99% of the mass in our solar system. This immense mass generates the gravity needed to hold the planets, asteroids, and comets in their orbits. Most stars in the universe are red dwarfs, small stars with relatively low temperatures and dim light. Despite their faint glow, red dwarfs are incredibly long-lived, with lifespans that can exceed 1 trillion years. The constellation Orion is one of the most recognizable patterns in the night sky. Its two brightest stars, Rigel and Betelgeuse, are among the most luminous and massive stars we can see from Earth. Betelgeuse, a red supergiant in Orion, is nearing the end of its life. Astronomers expect it to explode as a supernova within the next 100,000 years, an event that would be visible from Earth even during the day. When stars like Betelgeuse explode as supernovae, they scatter heavy elements like iron, gold, and uranium into space. These elements eventually become part of new stars, planets, and even living beings. The light from a star is created by nuclear fusion in its core. This process fuses hydrogen into helium, releasing enormous amounts of energy in the form of light and heat. Our Sun has been shining for about 4.6 billion years and is expected to continue its stable phase for another 5 billion years before transforming into a red giant. After a star like the Sun becomes a red giant, it sheds its outer layers, forming a planetary nebula. The core that remains becomes a white dwarf, a dense, hot remnant that cools over billions of years. White dwarfs are incredibly dense. A teaspoon of white dwarf material would weigh as much as a car. This density is due to the collapse of the star's matter under immense gravity. Some massive stars end their lives as neutron stars. These objects are even denser than white dwarfs. A sugar cube-sized piece of neutron star material would weigh billions of tons. If a massive star's core is heavy enough after a supernova, it collapses into a black hole. Black holes have gravitational pulls so strong that not even light can escape. The brightest star in the constellations, Cygnus, is Deneb. It is a blue-white supergiant and one of the most luminous stars visible from Earth, despite being over 2,000 light years away. The Milky Way, our galaxy, contains an estimated 100 billion stars. Each of these stars could potentially host planets, making the search for extraterrestrial life incredibly exciting. Stars do not last forever. Massive stars end their lives in spectacular explosions called supernova, while smaller stars quietly fade away as they become white dwarfs or even cooler, black dwarfs. The first stars in the universe, called population CT stars, were composed almost entirely of hydrogen and helium. These ancient stars likely formed less than 100 million years after the Big Bang. Stars are grouped into different spectral types based on their temperatures and colors. These types range from the hottest O-type stars, which are blue, to the coolest M-type stars, which are red. One of the largest stars ever discovered is UY Scuti. This red supergiant has a radius more than 1,700 times that of the Sun. If placed in our solar system. It would extend beyond the orbit of Jupiter. The Pleiades, also known as the Seven Sisters, is a star cluster visible to the naked eye. It is composed of young, hot stars and is located about 400 light years away in the constellation Taurus. The North Star, Polaris, is famous for its position almost directly above Earth's North Pole. It has guided travelers for centuries, yet it is not the brightest star in the night sky. Polaris is part of a triple star system. Its companions are smaller stars that orbit it, and together they form a gravitationally bound group. Stars in the Milky Way move at incredible speeds. The Sun itself is hurtling through the galaxy at about 800,000 kilometers per hour. Some stars emit powerful bursts of radiation called gamma ray bursts when they die. These events are the most energetic explosions in the universe and can outshine entire galaxies for a brief time. The smallest stars, known as brown dwarfs, are often called failed stars. They are too small to sustain nuclear fusion, but can still emit faint heat and light. Globular clusters are groups of tens of thousands of stars bound together by gravity. These ancient clusters orbit the centers of galaxies and often contain some of the oldest stars in the universe. The Sun rotates on its axis, but not uniformly. Its equator rotates faster than its poles, completing a rotation in about 5 days at the equator and 5 days at the poles. Pulsars are rapidly spinning neutron stars that emit beams of electromagnetic radiation. As they spin, these beams sweep across space, creating a lighthouse effect detectable from Earth. The first pulsar was discovered in 1967 by Jocelyn Bell Burnell. At first, It was jokingly nicknamed LGM-1, which stood for Little Green Men, because its regular pulses seemed artificial. The energy produced by stars over billions of years has filled the universe with light. This glow is called the cosmic optical background, and it represents the accumulated starlight from all stars that have ever existed. Shooting stars are not stars at all. They are meteors, small pieces of rock or dust from space that burn up as they enter Earth's atmosphere. A nova occurs when a white dwarf in a binary system steals material from its companion star, leading to a sudden and dramatic increase in brightness. Astronomers use parallax to measure the distances to nearby stars. By observing a star's apparent movement against the background of distant stars from different points in Earth's orbit, they can calculate its distance. The sun emits more than just light. It also produces a constant stream of charged particles known as the solar wind, which creates auroras when it interacts with Earth's magnetic field. Every atom in your body, except hydrogen, was created in the core of a star or during a supernova explosion. This means we are all, quite literally, made of stardust. Stars can form in vast quantities in regions called starburst galaxies. These galaxies experience a brief but intense period of star formation, creating thousands of stars in a short time. The Crab Nebula is the remnant of a supernova explosion observed by Chinese astronomers in the year 1054. At its center lies a rapidly spinning neutron star, or pulsar, emitting powerful beams of radiation. Cepheid variable stars are essential for measuring cosmic distances. Their brightness fluctuates in a predictable way, and the length of their cycle is directly related to their true luminosity, making them cosmic mileposts. The sun's light takes about 8 minutes and 20 seconds to travel the 150 million kilometers to Earth. When you look at the sun, you are seeing it as it was 8 minutes ago. In the southern hemisphere, the Magellanic Clouds are 2 small galaxies visible to the naked eye. They are home to millions of stars and orbit our Milky Way galaxy. The cores of massive stars can reach temperatures of over 100 million degrees Celsius. At these extreme temperatures, heavier elements like carbon, oxygen, and iron are formed through fusion. Black holes, the remnants of the most massive stars, are not actually empty voids. They are regions of space where gravity is so strong that it compresses matter into an infinitely small and dense point called a singularity. Some stars are part of open clusters, loose groupings of stars that formed from the same molecular cloud. The Pleiades and the Hyades are 2 examples visible in the night sky. Stars in the Milky Way orbit the galactic center, which contains a supermassive black hole called Sagittarius A. This black hole has a mass equivalent to 4 million suns. Not all stars die quietly. Wolf-Rayet stars, which are extremely massive and lose their outer layers through intense stellar winds, often explode as gamma-ray bursts at the end of their lives. Neutron stars have magnetic fields trillions of times stronger than Earth's. These fields can trap and accelerate particles, creating powerful X-ray and gamma-ray emissions. Blue straggler stars are a curious phenomenon. Found in star clusters, they appear younger and hotter than the other stars around them, possibly because they formed from the merging of 2 older stars. Solar flares are sudden eruptions of energy on a star's surface, releasing intense bursts of radiation. On the sun, these flares can disrupt satellite communications, and even affect power grids on Earth. A star's mass determines its fate. Stars smaller than 8 times the mass of the Sun end as white dwarfs, while more massive stars either become neutron stars or black holes after a supernova. Brown dwarfs, often called failed stars, sit between the largest planets and the smallest stars. They are too small to sustain hydrogen fusion, but can shine faintly through other processes, like deuterium fusion. The term supernova comes from Latin, meaning new star. Ancient astronomers thought these explosions marked the birth of a new star, not realizing they were witnessing the violent death of one. The brightest star clusters and nebulae often have poetic names. For example, the Horsehead Nebula in Orion is named for its distinct shape, resembling the head a horse against a glowing backdrop. Star colors can be subtle to the naked eye, but are vivid through telescopes. Albario, a double star in the constellation Cygnus, is a striking example, with one star appearing golden and the other a brilliant blue. Our galaxy, the Milky Way, is only one of billions of galaxies in the universe. Each of these galaxies contains hundreds of billions of stars, making the total number of stars nearly incomprehensible. Some stars orbit each other so closely that they share material. These are called contact binaries, and their interactions can lead to fascinating phenomena, including nova eruptions or even merging into a single star. The Sun's core is where nuclear fusion occurs. It is incredibly dense and hot, reaching temperatures of about 15 million degrees Celsius, enough to sustain the reactions that power the star. Stars do not live forever. When a star exhausts its hydrogen fuel, it evolves. Low-mass stars like the Sun expand into red giants, while massive stars may become supernovae, neutron stars, or black holes. supernova explosions, crucial for spreading elements like oxygen, carbon, and iron throughout the universe. These elements are the building blocks of planets, plants, and even our own bodies. The smallest stars, called red dwarfs, are also the longest living. They burn their fuel so slowly that they can shine for trillions of years, far longer than the current age of the universe. The Andromeda Galaxy, our nearest galactic neighbor, is approaching the Milky Way. In about 4 billion years, the two galaxies will collide, forming a new galaxy filled with countless stars. Many stars have planets orbiting them. These exoplanets are detected using methods like the transit method, where astronomers observe a star's slight dimming as a planet passes in front of it. The concept of a black dwarf star is purely theoretical. These would be white dwarfs that have cooled to the point where they no longer emit visible light. But the universe is not yet old enough for any to exist. Vega, in the constellation Lyra, is one of the brightest stars in the northern hemisphere. It has been studied extensively and was even used as the base star for the magnitude scale. The light from distant stars and galaxies often appears redshifted. This is due to the expansion of the universe, stretching the light's wavelengths as it travels through space. Stars form in cold, dense regions of interstellar clouds. These clouds can contain enough material to form hundreds or even thousands of stars, creating spectacular star clusters. The heaviest stars produce the heaviest elements. In their final stages, they create elements like uranium and gold, which are scattered into space during supernova explosions. Stars, like the Sun, are classified as main sequence stars because they are in the longest and most stable phase of their life cycle, fusing hydrogen into helium in their cores. In the future, the Sun will become a red giant, expanding so much that it might engulf the inner planets, including Earth. This phase will mark the end of life as we know it on our planet. The most massive stars can lose significant amounts of their mass through strong stellar winds. Over their lifetimes, they can shed material equivalent to many times the mass of the Sun. The farthest stars visible to the naked eye are about 4,000 light years away. Beyond this, the light is too faint for human eyes, but telescopes reveal countless more stars. The most energetic events in the universe are collisions between neutron stars. These collisions create gravitational waves and forge heavy elements like gold and platinum. The stars we see tonight are just a fraction of what exists. On a clear night far from city lights, you can see around 2,000 stars with the naked eye. But billions lie beyond our view. It appears I didn't yet reach 100 trivia facts in the last delivery. I stopped at 79 trivia facts. Let me continue adding the final 21 to complete the set of 100. Here they are. Massive stars can create exotic objects called magnetars after a supernova explosion. Magnetars are neutron stars with magnetic fields 1,000 trillion times stronger than Earth's, making them some of the most extreme objects in the universe. The James Webb Space Telescope is helping astronomers study the earliest stars in the universe. These ancient stars, born over 13 billion years ago, offer insights into how galaxies formed and evolved. Some stars can wander through space. Known as rogue stars, they have been ejected from their home galaxies, traveling alone through the emptiness of intergalactic space. The nearest star cluster to Earth is the Hyades, located in the constellation Taurus, at only 150 light years away. It is close enough to study individual stars in great detail. Quasars are among the brightest objects in the universe. These extremely luminous cores of distant galaxies are powered by supermassive black holes devouring matter, producing light brighter than trillions of stars. A rare type of star called a blue dwarf may exist in the far future. Red dwarfs, after exhausting their hydrogen, are predicted to shrink and heat up into blue dwarfs, a phase the universe has not yet reached. Stars near the galactic center often move in chaotic orbits due to the gravitational pull of the supermassive black hole at the heart of the Milky Way. Observing these stars has helped confirm the black hole's existence. Eta Carinae is one of the most massive and unstable stars in our galaxy. Located 7,500 light years away, it has experienced massive eruptions, creating a glowing nebula called the homunculus. Some stars have dusty disks surrounding them. These protoplanetary disks are regions where planets, asteroids, and comets are actively forming, offering a glimpse of how solar systems are born. The term light year is not a measure of time, but distance. One light year is the distance light travels in a year, about 9.5 trillion kilometers. It's often used to describe distances between stars. Wolf-Rayet stars are among the hottest and most luminous stars known. They are nearing the end of their lives and shed vast amounts of material through powerful stellar winds, creating stunning nebulae. The Large Magellanic Cloud, a satellite galaxy of the Milky Way, contains one of the brightest star forming regions, known the Tarantula Nebula. This nebula is home to some of the most massive stars ever discovered. Binary stars are not just a curiosity. They are common in the universe. Some stars in binary systems exchange material, creating dramatic changes in their brightness over time. The Sun's magnetic field flips every 11 years, creating the solar cycle. This cycle leads to periods of increased solar activity, including sunspots and solar flares. In Greek mythology, many constellations are tied to legends. For example, the constellation Perseus represents the hero who rescued Andromeda, who is also immortalized in the stars. The first exoplanet discovered around a Sun-like star was 51 Pegasi b in 1995. It is a hot Jupiter, a gas giant orbiting very close to its star, completing a full orbit in just 4 days.